Okay, guys, intro to Trig. So this is Trig, not the Trig that we did last year, not grade 10 Trig, not yet. That'll be day 4 and day 5 and day 6-ish. So this is day 1 and day 2. I'll probably make 2 videos here. This is a bit long. So we start off with what standard position is and a little definition. We start at 0 and we have a terminating arm, so a terminal arm. So we have a point here, and it ends anywhere. So let's say it ends at the point x, y. I'm in standard position if I start at 0, 0 and I end here. Okay, so that looks like that should be a straight line. So standard position if I start at 0, 0 and it's initial arm in the positive x-axis. So I start off like this, and when we measure angles here, we measure them positively this way and negatively this way. So remember that it's 360 degrees total. So if I had a angle that was here, let's say 22 degrees, that's positive 22 degrees. I'm in quadrant 1. So a bunch of things we're going to look at. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So all that stays like that. 1, 2, 3, 4. Remember this. There'll be a bunch of things that look something like this that you're going to work with. So there's quadrant 1 angle of 22 degrees. I have what's called a related angle. The first thing we're going to look at is related angles. If I spin all the way around and end up 22 degrees further from one spin, I end up in the same place. So these are called coterminal angles. And to get coterminal angles, you add or subtract 360 from your initial angle. So that would be 382 is a coterminal angle to 22. The other way I could go is down. So if I start down, I move all the way back and go this way. So that would be in the negative direction. So 22 subtract 360. And I believe that's negative 338. So 338 degrees turned this way or in the negative direction is all. I also end up with the exact same terminal arm. So 382 minus 338 and 22 are all called coterminal angles. Now the key one here is the principal angle of 22, because that's the smallest, or the only positive coterminal angle of the three that is between 0 and 360. So if I have another angle, so let's say I start off with negative 111, or let's make it easier, negative 160. Negative 160, I start here, I start turning, I turn 90 in this direction, I keep going, and I don't go all the way to 270, or 180, sorry. So I end up somewhere in this quadrant here, quadrant 3. Now, that's negative 160 this way, okay, so that's negative 160 this way. I can also try to figure out what my my angles are in the, my coterminal angles are in the positive direction by figuring out, here, I'll just change the color, what this angle would be from here to here. And to do that, I just add, like I said, add 360 and I get 200. And that's 200 degrees, which is nice because I know it's bigger than 180, because 180 gets me to the horizontal, and then another 20 gets me to 200. I could say, okay, what's this angle here? If I go all the way around and come back, well, that's an extra 360 from here. So I add that to here and I end up with 560. So I have coterminal angles of negative 160, 200, and 560. Which one of these is positive? And between 0 and 360, the 200, and that's the one that we call the principal angle. Okay, so that's the start of Unit 1. Then we get into the key, the special angles, okay, and we work our way through. We figure out that our special angles for sine, cos, and tan of 30, 45, and 60, and you don't have to memorize this. This will be given to you. Are 1/2 root 3 over 2. I just have this written down here so I can refer to it later. And that goes there, 1 over root 2. If you want to remember how we get this, you're welcome to look at our note, but you're not required to do that. So let me just get these down and stop mumbling. And this is root 3. So that's 1/2 there. Root 3 over 2, 1 over 2, root 3. So sine of 30 is 1/2. Cos of 45 is 1 over root 2, etc. So we also figured out that when we want to work out the trig ratios of given angles, we have things that are, so we'll save this for a bit. Let's go back to the trig ratios. Sine is equal to y over r, cos is equal to x over r, and tan is equal to y over x. So that will also be given to you. And where that comes from is if I have an angle like this and theta is my angle, I go over x and up y. This is r. This length of the hypotenuse is r. So if I said, hey, let me figure out what the sine of this angle theta is, well, sine is opposite over hypotenuse. So this is my opposite from theta. This is my hypotenuse from theta. So y replaces opposite, r replaces hypotenuse, and then x is your adjacent. So y opposite over hypotenuse turns into y over r. So if I was given this question here, and the one we did in the notes is, okay, 3, -4 is a point. Tell me all the trig ratios. Well, let's figure out what quadrant we're in here. So 3, -4, I'm down here. So I have the point 3, -4. So this is down 4 and over 3, 3, -4. I have to find out what r is. Use Pythagorean theorem here. It's going to be the c squared is equal to a squared plus b squared, or once I get a little further, it's the square root of a squared and b squared, which is 3 squared plus minus 4 squared. Any positive or negative becomes positive, so I have 9, becomes positive when I square it, so that's 9 plus 16, that's 25, so I want the root of 25, which is 5. So here, let's put this in red. Here, I have an x of 3, a y of -4, and an r of 5. So if I said, what are the trig ratios of this? Well, sine is equal to y over r, and y is -4, and my r is 5, so there's my sine, -4 fifths. Cos theta is x over r, and I got lazy here, but you should write sine and cos and theta and all these things. But cos theta here is going to be x, which is 3 fifths, and then tan theta is y over x, which is what? -4 over 3, or -4 thirds. So those are the trig ratios of that point. So just find, if you're given x, you're given y. Find what r is. R is always positive because it's the magnitude of this length. Okay, so it doesn't have direction. And then we go ahead and we figure out what the trig ratios are. So that was essentially the first day's work. So I think I'll call it quits here, and I'll start a new video. We're already 7 minutes in, so I'll start a new video. Let me just look at the homework to see if there's anything I missed here. Not really. Well, actually, no, let's go one step further. Let's figure out what this angle is here. So one way to figure out what this angle is right here is we take this -4. Okay, so let's go here. Sine theta is equal to -4 over 5. If I want to figure out, hey, what's this angle here? What you're going to do here is you're going to throw -4 fifths into your calculator. So remember, if you have a ratio and you want to find what sine is, you will, let me just find the calculator. You go 4 divided by 5 equals 0.8, make it negative, and then you hit second function sine or inverse sine button. Oh, I messed it up. So 0.8 negative, second function sine, and you get -53 degrees is your angle. So here my angle is -53 degrees, which is fine, and that is that, if I go to the point 3, -4, I end up, somewhere around -53 degrees. That's great. But let's figure out what the principal angle is here, and to do that, we're going to say we'll add 360 to this to find out what the principal angle is. And now I'm going to get a positive angle less than 360, and so now I'm at 307. So another way to look at this is that angle here is 307. Okay, so 307 is my angle. -53, same thing, to get me here, to get the same coterminal angle, or sorry, to get the same terminal arm. Okay, so that's it for this, and we'll go on from this. And you'll notice here, I went to this here will mess things up for the next part. So we'll get to this sort of thing in the next video, and we'll talk about related angles in different quadrants.